Back in the early 1970s, Stephen Hawking wrote down an astonishing equation. It would include relativity, it would include quantum mechanics, and it would include information. Hawking's rather simple equation brought us a step closer to understanding the relationship of quantum physics and black holes.
When an object crosses over the edge of a black hole, its event horizon, the object enters a realm basically of empty space, of darkness, and it continues to be dragged toward the center of the black hole, toward what we call the singularity, where it gets crushed out of existence. Every object, in some sense, contains information because it contains a very specific arrangement of particles. So where is the information that describes the arrangement of those particles? Where does it go?
Hawking's description of this process was that the energy remains, but the information disappears.
For many years, for decades, people wondered, is Hawking right? Is the information obliterated and disappears from the universe, or is it still there and perhaps can be in some way retrieved?
The destruction of information was counterintuitive, and it didn't match the rest of the things we knew. In all parts of physics, we had a situation where information doesn't get destroyed. So it was a bit puzzling.
This debate furiously went back and forth up through the 80s and into the 90s when people finally began to articulate this new principle, this holographic principle. And what it said is that all the things that were falling inside a black hole were somehow captured in a preserved image at the horizon itself.
So if the information is not lost on the surface, the information is not lost inside because they are equivalent.
All the information about those objects, what they were like in their three-dimensional existence, was preserved or encoded on the surface of the black hole. And that's a little bit like a hologram.
Well, that suggests that maybe that idea may apply more broadly to the universe as a whole. Maybe the three-dimensional objects, us, everything in the world around us, maybe all of the information in these objects is carried, is smeared around a distant two-dimensional surface that surrounds us, and we're just in some sense a holographic projection of that distant data.
The holographic principle tells us something quite astonishing. It says that our ideas of volume, of the real world in a sense, might be a kind of illusion.